Okay, this video is to explain the part in Lab 2 where we ask you to indicate the flow of current on the schematic diagram that uses the transistor, resistor, switch circuits along with the LED. Okay, so let's take this one at a time. All right, so let's first look at the inverter circuit. Okay, so what I'm going to do first is I'm going to use white to overmark this switch here and here. So now we'll be able to control the switch by drawing a line. Okay, so let's first put the switch in the up position. So the input is essentially a 1. All right, so on the input side, that's a 1. All right, and in the lab, they talk about transistors acting like voltage-controlled switches. I actually think of a BJT as a current-controlled switch, but that's a small technicality because if you have 5 volts, all right, so what does that even mean, this arrow? This arrow going up means there's a 5-volt source, a battery source, or whatever you want to think of, that makes a complete circuit, okay? And so when this switch is closed, all right, to this position, this resistor is looped in, and this base current can flow because there's some, this makes, let me show you the path. There's a path for current going this way, okay? All right, and there's a voltage source here that's on that gives it, the energy for current to flow. All right, so that's kind of technical, but let's rewind a little bit and let's just think of it like this, a simplified model. When the switch is connected, it's connected to a voltage source, so current can flow into the base. If current flows into the base, the resistor is on. All right, so I'm going to mark that as on, which means it's a switch. It's switched closed across these terminals of the resistor. All right, so now let's think about what that means. If this is switched closed, this is at 0 volts. Okay, so remember in circuits when we talked about potential difference. All right, so here is the reference. Okay, so with respect to the reference, 0 volts, if you had me for 1301, I talked about sliding the dot for reference voltages. There's never a voltage drop across a wire. So at that point, there's also 0 volts. Okay, if there's 0 volts, then plus minus here, this current is 0 going through the diode. Okay, so that means the diode is off. All right, so the question is, where does the current flow? And so what I would like you to think of is this 5-volt source. Remember, whenever you see that, think of there's a battery out here that's 5 volts. It's connected between the 5-volt arrow and ground. Okay, so if we were current, we would be flowing like this between 5 volts and ground. Okay, so that's the current flow. All right, so you can redraw that in a simplified way for your lab report, where we would just say when the switch is in this position, the current flows from 5 volts down to ground through the resistor and the transistor. All right, so that would be the picture I'm wanting to see. Well, I'm only going to have you do it for the final mystery circuit, okay? But this is picture number 1. Picture number 2 would be I put the input, that's a terrible N, I put the input to 0, all right? So if I put this to 0, there's no voltage that generates a current. This current coming in here would be 0. So this transistor is off. And let's draw our circuit back in so we see the path. Here's connected to here, it's connected to here. All right, so what is our path? If this is off, then the current is going to flow. It can't go straight down. Sorry, let me undo that. It has to go this way through the LED. That's the only place it can go because this resistor is open. Okay, there's no connection here, or you can think of it as a really big resistance. All right, so if we simplified that, we can get rid of this loop. The loop is really there, but we have a shorthand notation for representing the loop. Okay, the current goes in this direction. All right, so this would be the diagram I'd want for the second input combination. Okay, so next I want to do the 4 combinations of the switch for the OR circuit, the NOR circuit, and then you can do the mystery circuit. All right, so what I want to see is 4 diagrams just like this, only using the mystery circuit with the current path indicated, rather than the NOR gate circuit that I'm about to do. All right, so what I'm going to do first is I'm going to get rid of the switch positions here so I can choose those. All right, so let's do that in all 4 diagrams. Okay, so first, let's go with 0, 0. All right, 0, 0, I make that connection, and I make this connection. Okay, so using the logic that we talked about before, this is 0 volts, so there's no place for current to be generated. You know, this is the loop, right? It's just a little tiny loop, no current. All right, so because that's 0, this is an open. All right, since this is 0, no current coming into the base, this is open. What is the only path for current? Well, the only path for current is to make this loop between 5 volts and ground. All right, because current is flowing through the LED is on. All right, so that's combination 1. Okay, combination 2, I do 0, 1. Okay, so this is 0, this is 1. Okay, because this is 0, this would be an open. This would be a short. Okay, so from there you can say, well, if I'm current, I'm going to go here. I can't go down because that's an infinite resistance, but this is essentially 0 resistance, so I'd have a path down to ground. Because I have that path down to ground, I wouldn't have any, or at least I'd have very small, almost 0 current going through the LED. Not enough to light it up, and therefore the LED would be off. Okay, and so from the symmetry of it, you can see if either one of them is a 0, you're going to have that scenario. Okay, so if I move this up to a 1 and this one down to a 0, okay, this one's now open, but this one's now the short, and the path for current is this way. And there's no current or very small current coming here, and so this also is off. Okay, and then finally, there's the case, I lost one of the cases. Let's go up here, I just skipped it. So 1, 1, okay, the transistor is shorted. Okay, so current can flow through either of these paths, but there's a path directly to ground. And so because of that, very little current here, and so the LED is off. Okay, so I want you to do the same logic for the mystery circuit. You have more transistors, but there's only 4 combinations of the switches. All right, and so use the logic that if there's current that goes into the base, it turns the transistor on, which shorts it. Or if there's no current going to the base, it turns the transistor off, which opens it. Okay, looking forward to seeing your work.